Hello everyone, it's GooseX back here with another programming video. So this right here is a programming video that been wanting to do for quite a while, but haven't gotten around to it. And it's a really simple tutorial, but it's something that people really don't quite know how to do, and that is very basic 3D rendering. And I mean very basic as in like this is really simple, but you can do a lot with this, and so yeah, let's jump into it. So in order to do this, we're going to be using some relatively simple calculations that I'll be showing you to find a point in three-dimensional space and change it into a point in two-dimensional space. So what we're going to do is we're going to use a very simple thing, equation, and I'm going to write this in pseudocode. So it's going to be a two-part equation, one for the x and one for the y. So system of equations. And it is the screen's x position is equal to the x position of the point divided by the z position of the point, and then multiplied by and then for very basic rendering, we'll do multiplied by the width, and that'll create a 90-degree FOV. The 90-degree FOV rendering, and then for the y, we just change it to the y-axis. However, we're going to leave this width because otherwise, if your width and height aren't equal, then it will start to look weird. So I just like to leave it to width. You can make this width more complicated. For example, if you want changing FOV, I believe the math for that would be is like n equals 180 divided by FOV. It's something like that. I can't remember the exact equation off the top of my head, but you can play around with it a bit to get changing FOV and stuff like that. But for right now, we're just going to do very basic 90-degree FOV by multiplying by the width of the screen. Alright, so now let's actually do some rendering. So first things first, let's do a var points 3D that we're going to do as a function. We'll give it an x, y, and z, and this will just be a test thing. So we'll assume, for the sake of simplicity, that the camera is situated at the point 0, 0, 0. And what this math basically does is we're going to take the x position that it's at, and we're going to divide it by the z position. And if that's visible in 90 degrees FOV, that will be a number between 0 and 1. So let's play around with this a bit. So first off, FOV2 equals width. You can change this calculation if you want, but I just like creating a variable. So next we're going to say, we're going to draw, for our point 3D, it's pretty basic, we're going to draw a point, and we're going to use these calculations. So x divided by z times width, and then y divided by z times width. And there we go, now we have a point 3D, and let's test this by saying, okay, point 3D, and we'll place it, I don't know, give it a 200x, 200y, 200z. No, we'll say 100x, 100y, and 200z. And that should draw a point, yeah, and you can see it there. Little speck thing. One other thing that I forgot to mention, this draws relative to the center of the screen. So we're going to have to quickly, I'm just going to encapsulate this in a draw function. And add a background. This is good practice at any rate. Add a background. So what you're going to want to do is quickly, to make this go in the center of the screen, because that simplifies the math by a huge amount, just do this. And that'll move it to the center of the canvas. I'm not going to explain that because you should already know what all these things mean. If you don't, there's already tutorials on KA that explain how push matrix, pop matrix, and translate work, I believe. I think it's one of the advanced JavaScript things. But what this basically does is we've now set the center of the canvas to be the center of the screen. So we can now render a point 100, 100, 200. And it should come up over here, but I think it's just too small, so we're going to change this to be an ellipse. That way we can give it some size. And it looks like it's going all the way down here, which I find interesting. So I think we might need the FOV too to be half the width, which is fine. Yeah, that's right, half the width. So in the end, our mathematical calculation is x pos over z pos times width over 2 and y pos over z pos times width over 2. And you can see that creates a point there. And if we go around, we can create a bunch of points. And you can see we are actually getting a 3D rendering of an object on the screen. And this is the very basics of how you do this 3D rendering. And then from here, it's really simple to add shapes. All you're going to do for a shape is you're going to say var, everything in games is usually made in triangles, so I'll just make a triangle 3D function. We'll say it's a function that has x, y, z, x, or actually wait, there's going to be a lot of x's and y's and z's, so we'll say x1, y1, z1, x2, y2, z2, x3, y3, z3, and that's a basic triangle function. And then we can just say, alright, so now we're going to take our basic calculation, make it a triangle that we're going to have go to all 3 points. And of course this is wrong right now because I haven't specified which x and y we're using, but that's pretty easy to fix. We'll just go ahead and do that. And what we should get is we should get a function that we can then use to draw shapes. And then we can use like different fills and stuff. So I'm just going to quickly, I'm going to leave our points here. I'm just going to add a triangle 3D, and I'm just going to use some of our existing points. So let's just take like this one and use go to if I could speak, that would be nice. So what I've just done here is I should have created a triangle. Oh, except I can't spell. You know, spelling is a very nice thing sometimes. But what I've just done here is I should have created a triangle. Why did I not? Oh, because I was dumb and made these 2s when they should be 3s. And there we go. Now we should have our triangle in all its beauty. And then by continuing to place this shape, we can tessellate the shape among the points and create a rendering. I believe the point that we'd want to move is this point here, which is 100 on each. So we just change that to a 300 on each, 300 and minus 100. And there we go. We've now created a face of a shape over here on the canvas. And this is all a 100% 3D rendering. Like if I were to change the values, it would all move around and look 3D. To show you what this would look like, graphics engine update 2, here we go. So I've turned this into a full graphics engine before, and I mean it's rudimentary, it's basic, but it does work. And you can see by using this very basic system, I was able to take tons and tons and tons of triangles and make them all render into a full 3D world. What's great about this is that it uses the same super simple algorithm that I just did over here, and it just moves the points around, and that's all it does. So for rotation, you're going to want to use basic trigonometry. I can do a video on that. So anyways, I'm just going to leave that here with this beautiful view of my different objects and the FPS counter and 256 triangles that got drawn on the screen. And it's all thanks to this very basic algorithm. So that's how to do 3D rendering, the very basics of it. And then you can just combine that with your basic knowledge of trigonometry, or go learn trigonometry if you want to. That's what I did. That's all for now. And I will see you guys all next time.